In this video, we'll learn to use the formula to find volumes and surface areas of 3D shapes, including cylinders. At level 1, we learned how to work out the volume of cubes and cuboids. And if you recall, the volume of a cube or a cuboid was worked out by multiplying length times width times height or depth. So it was 3 dimensions and our answer was in cubic meters, centimeters, millimeters, and so on. So what I want us to look at first is how to work out the volume in another way, or look at another perspective of working out volume. And to help you with that, I want you to think in terms of what do we get when we multiply length by width? And that is the area. So volume can be worked out by multiplying area times the height or the depth. So we'll show you what that means. So I've got a cube here, and as we know, volume is about how much you can put in or how much space it takes. So I've put in some jelly inside and I've just got it out. So if I cut off the top bit, I can make this into a 2D shape. And what volume is that surface area repeated so many times. So there are layers and layers of it within the shape. So if I stack them up again, that would make the volume. So that is another way of working out the volume. Another perspective which is going to be very helpful when it comes to other shapes as well, because the same thing applies to cuboids, the same thing applies to cylinders, prisms. Because if I show you this, so this is a cylinder, and as we said, that's the surface area of it, and that surface area, as you can see, if we cut it in slices, we'd have many of it to make the volume. So this repeats itself throughout. This is what we call also the cross section, because it's the same throughout the height or the depth. So if I get this out and I cut a slice of the circle, the cross section, that is going to be the same again and again. So it's really difficult to show, but the idea is that the same surface area continues throughout the depth or height. And exactly the same thing happens here. So I've got a triangular prism filled with jelly, and this is the cross section. And if I cut slices of this, I'd have many of them throughout the height or the depth. So if I work out the surface area of this and I multiply by the height, then I would have the volume of the shape. And the same thing here, if I work out the surface area of the circle or the cross section, the same, and then multiply it by this length, which we call the height or the depth, then we'd have the volume being worked out. So let's work out the volume of this prism. So if this is 4 centimeters, the base, and the height being 5 centimeters. So the surface area of the triangle first would be 5 times 4 divided by 2. So 5 times 4 is 20, divided by 2 is 10. So I've worked out the surface area of the triangle or the cross section first. So that is 10. Now we said that is being repeated throughout, so we're going to multiply it by this, the length here, or the height. So then it would be 10 times 6 equals 60 centimeters cubed. So that's the volume of the prism. So in other words, to work out the volume of the prism, we worked out the area of cross section, multiplied by height or depth. So that's how we work out the volume of the prism. So if we want to work out the volume of the cylinder, then again we said we work out what is the area of that cross section, and that's the circle here. So the volume of cylinder, again, area of cross section times the height. So area of cross section, how do we work it out? So if the radius is equal to 2 centimeters, then what do? We do pi r squared. So r is 2, 2 squared is 4, so 4 times pi. So 4 times 3.142, and that gives us 12.568. So I'm going to keep it the same there, and then what do? We multiply this area by this height. So if this is 7 centimeters, all I do, get the answer and multiply it by 7. So this gives us 87.976 centimeters cubed. So 87.976 centimeters cubed. So with these shapes that have a cross section which repeats itself throughout, so you have a circle, it continues to be a circle up to the other end, or with a prism here that we have a triangle and it continues to be a triangle up to the other end, same as a cube. So it has a cross section which is the square, and a cuboid which has a square and that is repeated throughout, and we get a square at the other end as well. So with these shapes, the formula of volume is straightforward. Work out the surface area or the area of the cross section and then multiply it by the height. What about shapes like a cone or a pyramid? Because they don't have a cross section, we start off with a circle and we end with a point. And the same thing here, we start off with a square and we end with a point. It has a pointy, both have pointy tops. So what do we do in this case? And this is what we're going to look at now. So we'll try and make that link now between the shapes with a cross section and the shapes that are pointy, like the pyramids and cones. So if I ask you to compare these two, what do you notice in between them? So these two shapes have the same height. So this height from the bottom to the top is the same as the height of this cube. So the pyramid that I have and the cube have the same height. And this area is exactly the same. So they have the same base. The only difference is that, of course, so this is a pyramid and it starts getting smaller and smaller till it becomes pointy. That surface area at the top, at the bottom, the base gets smaller and smaller to come to just a point, whereas that doesn't happen with a cube. So I wonder whether there is a relationship between the two volumes. So if I try and put, because I can see this has a smaller volume, I can see that. So if I try and put the jelly into the cube, how many of these would make a cube? So I'll try and put it inside. So I've put one and it's not filled. So I'll try and put another one to see if that fits and if it fills it up. And as you can see, it doesn't yet. So I'll try one more. And with the third one inside, it makes exactly the volume of the cube. So exactly 3 lots of the pyramid made the cube. So in other words, what we're saying that the volume of one pyramid is 1/3 of the volume of the cube with the same base and the same height. So having the volume of the cube already here, which is length and width and height, or volume of the area of a cross section, volume equals to area of cross section times height, I can say is that the volume of the pyramid is equal to 1/3 of length times width times height. Or the other alternative would be equals to 1/3 times area of cross section times height. So that's the base as well. So this is just to help you, but the reason this isn't an official formula. So if it helps you remember, then use it. But this is the official formula. And this makes more sense because in a pyramid, you really don't have a cross sections, but you have it in the cube. So if you try and make the link between the two, then that's perfectly fine. Now, my next question is this the case when it comes to a cone. So let's have a look. So I've got 3 cones and I've got a cylinder which has the same base. So I'll try and empty these into the cylinder to see whether it is 3 that make the volume of it. So I've done one and there is another one and still not filled. So and that is exactly it. That is the volume of the cylinder. So we can say the same thing for the volume of the cylinder. So I'll put down volume of the cylinder is equal to 1/3 of area of base times height. Now, area of base, what is the base when it comes to a cone? That is the circle. So the circle, we work out the area by multiplying pi r squared. So we can have that instead of area of the base. So let's illustrate with examples. So we have a pyramid, and let's suppose this is 3 centimeters and this is 3 centimeters and the height is 4. So surface area 3 times 3, which is 9. 9 times 4, which is 36. So 36 then divided by 3, because we said 3 lots of them make a cube. So in other words, is the same as saying 1/3 of 3 times 3 times 4. So that was 9 times 4 is 36. 1/3 of 36 is 12. So 12 centimeters cubed. You could do it with a calculator as well. So 1/3 of, so times 3 times 3 times 4 equals 12, or just do 1 divided by 3 times 3 times 3 times 4. So that still gives us 12. Or you could do 1/3 of 3, which is just 1, times 3 is 3, times 4 is 12. So there are different ways of doing this. And let's have a look at an example of a cone. So we said 1/3 of pi r squared times h. So it got 1/3 of, if the radius of this is, like we said in the previous example, 2 centimeters. So pi r is 2, so 2 squared times h, which let's suppose is 4. So from the base to the top is 4 centimeters. So we could plug this into the calculator because we have pi, but we could do it ourselves as well. So 1/3 or 1 divided by 3 times 3.142 times 2 squared is 4 times 4. So that gives us 16.7573. That is recurring, but we don't need to continue adding 3's. We can leave it like that, so rounding it, and that the unit is centimeters cubed. So again, when we work out volume, it's cubed because we're looking at 3 dimensions: length, width, height.